That's the one I want. Make sure this is going live in a sec. Yeah, we're good. Okay, and then let me auto-find activate. Bum, 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 bum. Should see it. Does it not see it? This is so weird. I gotta add it by the manual like thing. It's ugly. Fine. Delete this one. YouTube video ID. Yes, this is YouTube Shorts. Go. Go. Activate. Go Power Ranger. Nice. Test. Does that chat work? It does. Nice. Anyways, yeah. I was gonna say if any of my UCLA students are watching, I did get through all of the second midterm partial credit requests, and the final exam partial credit requests are due Thursday, so I'll probably start churning through some of them today, but I'm gonna leave the final group to do what's up, Sib? The final group of I'll do that like maybe Friday morning, Friday afternoon. There's also like still a lot of errors with Canvas. So Canvas is an LMS. It's a learning management system is what they call it. And that's how like the grades get inputted and everything. But then there's also like grade scope as well. Dude, there's all these fucking things. Like, I hate all these softwares. Anyways. Great. Yeah, you're turning yours in. Awesome. Yeah, good to see you, Mistral. Yeah, so yeah. And then I have to get final grades inputted over the weekend. So that's next. Yeah, Mistral, I was just saying what's up. I was telling the viewers here that it's kind of like a love-hate thing that I don't have to teach right now. I kind of love that I have all this free time now, finally. Like, I'm not worrying about opening homeworks or, like, setting up quizzes or blah, blah, blah. But then also I kind of miss it because it was nice having a task. Or actually, it was really, like, a big series of tasks. But I was getting in the groove. I was like, ooh, I could do this.
Hello.
What's up, Ethan?
That's good.
Nice, Mistral. You're free for the rest of the summer, too? Yeah. I'm free for, like, 2 weeks. Then I got to go to Burning Man. So, I mean, I'm, like, free, but there's a lot of work involved with getting Burning Man to be successful. What's up, Nick? Good to see you too.
Hey, well, how's it going? First of all,
how's it going? It's going great. I'm chilling. I was telling people I'm chilling right now. Sib says they're free for the rest of the summer as well. What are you guys doing for the summer? Tell me.
let me tell you,
it's hot.
Just next week I have school already.
Uh-oh. You have school already? That's unfortunate.
Next week. I only have this week to relax. Then it's back to school and work at the same time.
Yeah, I was saying though, like, I kind of don't like relaxing for too long. I start getting antsy. I like don't know what to do with my life.
Nice.
I want to go do things.
I can relate. I can
also
find
a million things I should do, but yeah.
I have to tell you this. Like, just yesterday, my country, Belize, implemented a new currency. They changed the bill signs.
Wait, completely? There's a completely new currency for Belize? Sorry, what's going on here? Or what?
Yes, it is. It is. Like
I
really just didn't expect this. But look at it yourself. I like the old ones much better than the new ones. They remind me of Mexican pesos.
Belize new currency. Somebody says, I'm not sure, but I'm going to start studying before next quarter once the grades get finalized. Yeah, that's probably a good idea. Get ahead. Mistral says, school doesn't start until the end of September. Thank God, I needed a break. Physics started 1 week when... Yeah. And you know the next physics session is already on, like, day 2. The summer C session, which... That's ridiculous that there's not even a week of break. It's literally back to back. Like, I'd be teaching another physics session and I wouldn't even have my previous session, like, graded. That's nuts. I guess they really just try to, like, cram it in. But, yeah, I turned that down because I wanted to go to Burning Man. And, like, it's too much. It is too much, Sib. Okay, so Belize removes Queen Elizabeth's image as a step in decolonization. That's cool. Okay, here's the fresh banknotes. What's up, Helen? You want to come say hi?
Like these ones, I really cannot get used to.
Let's see. Let's take a look at them. They look pretty fucking cool, man. Well, you got like tigers and shit. What is this? Like cougars?
You could say so. Those are like our
who's this guy?
animals.
Is this guy like the president of Belize? Like, what's going on here?
He's like a national hero of Belize. He died
that's cool,
already
man.
a long time ago.
Wow.
His name is George Kittle Price.
That's cool. George Kittle Price. Is that what you said?
Yes.
George Kittle Price.
We're
gonna learn some
one of the national
Belizean.
heroes of Belize.
Wait, national hero of Belize.
Yeah. Like search them up. You'll get a couple of them.
Okay. Order of the National Hero. Oh, George Kittle Price. This is him. That's cool. He was the first prime minister of Belize. Nice, dude.
Yep.
When it was British Honduras. Yeah. Mistral says, I'm happy with my final grade as of now. Thanks for making a memorable quarter. You're more than welcome, dude. I know some people, once they got the exam to regrade and they saw they had like an A- or an A or whatnot, they're probably like, all right, I'm chilling on the final. I don't care anymore. Which I kind of do like, because that does alleviate a little bit of grading I have to do. Because some people are like, I already have an A. Like I don't need more points on the final. I'm like, yeah, good. Drew Taylor, do you remember me? Remind me. I mean, we've had thousands and thousands of students come through the Discord and the Twitch, so I might remember you if you give me like another username or something. Dr. Gold, I submitted a question in the app. When will you help me with your question? I'll help you right now. I didn't know we had questions. I thought we were just chilling. Let me see one sec. We do have questions. Oh, Taylor submitted one. Nice. And Taco. Good job, guys. What were you saying, Ethan?
I'm just saying it's like it's going to be hard for me to adjust to this new one. Like they'll keep the old ones for now, but pretty soon they'll die out, and then I'll be forced to use these new ones.
Yeah, I mean that's change. I was
just saving up on some money.
Well, you can always just like exchange your money for like other stuff, right? No. Yeah, you can exchange your old money for the new stuff. Wait, I think I know who Drew Taylor is. Drew Taylor, did I talk to you in the front office channel? I think I did at some point. Okay, that's totally cool. You're fine, dude. All right, you need help with this question? Are you in my Discord, by the way, Drew Taylor? It's just sometimes because the lag is a little bit hard over Twitch, but if you watch on Discord, it's pretty instantaneous. What's up, Gmail user? Good to see you, bro. Taco, okay, I got some matrices for me to work through. I like that too, Taco. Are you the teacher? I am a teacher, but other people help as well. Yeah, that's totally true. Okay, let's see. The average speed of the object between points C and D. Okay. This is good to know, like, what the definition for average speed is. Oh, dude, attitude error? What's attitude error? Is that when it was the WWF? Alright, average speed. That's equal to distance traveled. Hell yeah, brother. Gmail user, did I tell you I've met John Cena? Like, well, I didn't like really introduce myself, but he was working out at the gym I was working out at, and I was like, dude, that's fucking John Cena. I wanted to go over, like, he was bench pressing. I was gonna go over and ask him, like, yo, do you need a spot? I didn't do it though, because like someone did go over like trying to get like a picture of him. He looked pissed as fuck. He was like, no. Okay. John Cena. Distance traveled. All right, so between points C and D. Wow, isn't he invisible? Is he? Is John Cena invisible? Okay, from here to here. Toxic Febreze. What's up, Toxic Febreze? That's a cool username. I think all Febreze is probably toxic, honestly. So distance traveled. technically this is defined as the absolute value of like x final minus x initial, because distance doesn't really have a direction, and we only count like positive distance and stuff. Sibyl, you don't know who John Cena is? What? I guarantee you've seen the memes. All right, so x final here is 5, x initial here is 2. So distance traveled is equal to 3. Okay, so we got this. Will the average speed between B and C be 0 since... Yes. Totally. Yes. Yes, that is true. I mean, sorry, I'll show you the trick there for that, but... yeah, so this is 3, and then the time between C and D is 10 seconds and 18 seconds, so that's 8. So this is 3/8. You should know this. This is a pretty common fraction, Drew. 3/8. 1/8 is equal to 0.125. So 3/8 would be 3 of those. So it's 300 plus another 75, so it's 0.375. Oh, yeah. You know, I mean, John Cena's like an actor. He used to do like wrestling and stuff. Here's kind of a cool thing. Drew, let's say you wanted to do the average speed between B and F. Okay? Yeah. How do you know if it's meters or kilometers? Oh, it's kilometers per second because the units up here are kilometers. And then, oh, this is kilometers per minute. Oh, we fucked up. No. Oh, I'm really sad there, dude. Oh, I screwed up. I really screwed up, dude. I'm sorry, dude. Oh, no. I'm making my first error of the day. Oh, shit. I didn't see that. Yeah, oh, it's tricky. Okay, so this is 0.375 kilometers per minute. Wow, these people are being mean. This is mean. That's so mean. Wait, can I just copy that, please? Thank you. Oh, no, not that. Sorry. Copy paste is not working today. Okay, there we go. All right. No. Copy. Am I hitting Control C correctly? Okay, I'm done. I'm done. This doesn't want to copy the right thing. There it goes. Okay, fine. All right, here we go. So you need to convert this. So we're going to say like how many meters per second is equal to this 0.375 kilometers per minute. What's up, Lily? So this is called stoichiometry. Multiply by 60. So yes. No. I'll show you why. Yeah, we help people with homework. Yeah. You can submit a homework question too if you want, Lily. There's a link down there. Submit.actual.education or actualdiscord.com/submit. That one works too. So look here, if I want to go from minutes to seconds, you have to do this. You have to do that. There are the conversion factors, and one of them is 1 minute is over 60 seconds. Do you see how minutes and minutes is going to cancel here, Drew? And then you're going to be left with kilometers per second. And then the last conversion you need to do here is you're going to say that, okay, well, 1 kilometer is equal to 1,000 meters. I know, it can get really confusing, like, which one, like, divide or multiply by. But if you set it up as the fractions and you try to get the units to cancel, you'll always do well. You do a good job. Wow, thanks, Lily. Your universe... Oh, UTSA. Cool. Nice. Is that... Wait. What is the mask... I went to University of Texas at Austin. I forget what the mascot for UTSA was. It's not the Horned Toads, right? Because that was TCU. UTSA... It's like the Cowboys, maybe, or something. Yeah, stick around. Very cool. The Roadrunners. Okay, that's what it is. Okay, cool. Yeah, my ex, her parents taught at UTSA. I remember that. Okay. Or they taught architecture. I don't know if you do architecture. So then you multiply this through. So this is 0.375 times 1,000. So, Drew, if I got 3 zeros here, that means I move this 3 places. So then this is 375 over 60. And kind of ballparking that, right? That's like 6 point something. Because if it was 360 over 60, it'd be 6. Nerds. We're the biggest nerds. Wait, that's none of these answers. Oh, I see. Yes, sorry. Wait. Wow, this is even more screwed. Oh my god, what? Okay, they want everything per second, but they don't want kilometers. Okay, so yeah, look what happened there, right? So we tried to do 375 divided by 60 meters per second, but that doesn't show up as any of the answer choices, right? So instead of doing the kilometers conversion, I'm just going to do the kilometers per second, and that's going to be 0.375 divided by 60, which is still, dude, none of these answer choices are correct. What? Oh no. Okay, did I do something? Did I do a bad job? I don't think I did a bad job. Yeah. 5 to 2, distance is 3. Yeah, let's see the graph again. All right, Jeff. There you go. There's the graph. Right? 5 to 2, that's 3 kilometers in 8 seconds. So that's 0.375 kilometers per second. Yeah, right? 3 kilometers or 8, yeah. 8 minutes. Yeah. Sorry. Yeah, sorry. 0.375 kilometers per minute. Sorry. That's what I meant to say, Drew. But then if I do 1 minute over 60 seconds, right? Because everything here is in per second, right? That gets me a really low number. Right? That's going to be like point... I mean, here, I can get my calculator out, but I don't think it's any of those answer choices. Teacher done goofed. It happens. They tried to trick me, then they tricked themselves, dude. Yeah, if I do 0.375 divided by 60, that's going to get us... Oh, thank you, Gmail user.
My man.
Yes. Yeah. We attract all sorts of people on the stream. I say learning has no limits. Like, doesn't matter where you are in life. You can always learn more things. I will say I primarily help out, like, high school and, like, early college students, but I have people, you know, in their 40s, 50s, 60s that are going back to school or, like, just trying to relearn some shit. Okay, so this would be, like, kilometers per second. That doesn't make any sense, though, right? And then even if I do, like, 375 divided by 60... that's also 6.25 meters per second. I love you too, man. So I don't think this has any correct answers. I think your teacher like really screwed up. If I want, you want to throw this thing at AI? Let's see if AI like breaks itself on this. It's always kind of fun. See what AI wants to do. It is 3 kilometers over 8 minutes. The issue are the answer choices they gave. So here, I'm going to like solve this. Just go. Go solve it for me. Yeah. Average speed. Good. There we go. 6.25 meters per second. Wait. Mistake detected. So... wait. The distance from C to D is actually 3 to 4.5? Dude, it's just trying. It's like, nope. Did you look how much it's trying? Yeah, it's just, yeah, look. It took AI this much effort to realize that, like, wait, this thing is screwed up. I love doing that. It's just, yeah, just have the AI choke on it. Your textbook is wrong then. I don't have any teacher currently, so I can't ask any teachers. Well, you came to the right place, buddy. 'Cause we do this 3 times a week. For like 2 or 3 hours. And also, I'm not the only person that does streaming on Twitch. Another really good person, if you want to learn about math specifically, I teach physics, chemistry, whatever. A lot of math as well. E to the 2I Pi is streaming this summer as well. He's a really cool guy. Make sure to follow him on Twitch too. Maybe the teacher used AI to write the problem. Yeah, could have. That's India. You're very. It's an astute observation. Could have happened, yeah. I need multivariable calculus and linear algebra. Yeah. Take multivariable first and then take lin alg. If you want help with linealge, I have a really good textbook I like to use. I can send it to you, Sibley, if you want. If you want to like get a head start on that. In terms of multivariable, that's primarily like vector calculus and stuff, which I think I have a book for that. One sec. Where's my calculus book? Yeah. Yeah, I like this. I like Rogowski for calculus. And then if you look at... This is kind of like all 3 calculus courses in one book. So like Calc 1 at UCLA at least is usually like limits up to differentiation, up to like chapter 4 here. Yeah, you're welcome, Drew. And then chapter 5 is like integrals. Oh, Drew, you get a point as well for asking a question. So you were asking me like how this Discord works. So we originally started up as, I mean, we still are a nonprofit, but I originally started this Discord as a way to get kids who play video games to like learn math and science, and we still do. We still play video games. We had a Fortnite tournament over the weekend, but we reward students with like video game gift cards and stuff if they like ask questions. So if you play any video games, anything PlayStation, Nintendo, Xbox, I don't care, Steam, and you ask questions during the stream, you get points, and points equal gift cards, and gift cards equal fun.
That's dope.
But yeah, so then Calc 2 Sib would be up to chapter, oh man, I want to say 8. I forget in Calc 2 if you do Taylor series. Yeah, not too much. Yeah, that's totally cool, man. Yeah, my parents used to like hide the computer cord from me. My dad wouldn't let me have the computer cord to like turn my PC on unless like I practiced the cello for 30 minutes or I read a book for an hour or something. It was really funny. I don't think parents in today's world do any of that anymore. It's 32B. Oh, let's go look it up. Let's see, look up UCLA 32B class. I just want to see what it's defined as. And then Taco, we'll do your question. Then Nick, I know you got some as well. So, all right, there we go. Okay, yes, all the integrals and Green, Stokes, and divergence. Taylor series is Calc 2? Okay, thanks, Mistral. Yeah, for sure, man. Yeah, we teach all sorts of things, Drew. So, like, you know, I'll do a little bit of math. I'll do some physics. I'll do some chemistry. I'll do some stats. Like, we get all sorts of questions. I mean, I think so far I have a bunch of math questions. I mean, you gave me a physics question. Nick says, my parents say, fuck the cord. I'm taking the cord and the laptop and everything else. Yeah. Well, because they know you'd probably just go find another cord. Okay, so that being said, Sib, you are probably going to do this. I would say chapter 12, parametric, vector geometry, vector calculus. And I don't think you would... Yeah, differentiation in several variables for sure. And then, yeah, multiple integration, and then this. So it's basically... Oh, and then up to Stokes' theorem. So I think it's everything from chapter 13 to chapter 18 is what 32B is. So yeah, if you want... Here, I'll copy a link for you. There you go, Sib. Just go download that Dropbox link. That's a textbook that I like to use. And you can start... It's a really good textbook. Like, it teaches very well through the examples that they have. And if you want to get a head start this summer, you can start, you know, going through that. I mean, you could start with chapter... I don't know, probably chapter 12 maybe? Or chapter 13, really. Just start with chapter 13 and start working through some of the homework questions. Yeah. I'm going to be studying this so hard. Yeah, you're welcome, dude. Welcome, Sib. Hated Calc 2. Yeah. I like Calc 2. Integrals are fun. Okay. Let's see. We got some other screenshots. Ethan, you got a good one, too. That's physics. Taco Cat, where are you at? Taco Cat. Sir Taco. Are we learning about matrices today? Nice. Okay, what's up, Taco? Okay, cool. Here, let's do yours. Okay. Matrices. This is technically linear algebra. But okay. Cool. This is adding matrices which are fairly straightforward. Okay, so yeah, these Jeff says boring matrices. He's like, these are boring ass matrices, dude. I can show some harder ones later. Yeah. But yeah, this is what we call. They're not exactly fractions. This is a structure of numbers. So this is what's called a 2 by 2. This is a 2 by 2, and this is a 2 by 2. Okay. So you can think about like it's you have a bunch of numbers that are in different like boxes, like different places. And depending what you do with these data structures, you have rules for like which boxes do things to other boxes. So the rule with adding matrices, you play some Pokemon, nice. Which one, Ruby? Wait, the rule with adding matrices is they all need to be the same dimension. Okay, you can't add matrices that don't have the same dimension. So you have to check that these are 2 rows by 2 columns on both ones. 2 rows, right? 2 columns. Yeah. Okay. So if you wanted to add these whoa, they have black and white for Pokemon, really? Back in my day, it was red or blue. That was it. And then they introduced yellow. My parents wouldn't let me have Pokemon cards. This was back in, what was this? Probably 2003, 2004. So I had to, like, smuggle them through school. Exactly. Yeah, they have to be the same format. So here's the rule. If you want to add matrices together, you just need, you need the positions to match up. Yeah, I know. There's so many generations of Pokemon. Back in my day, there was only 150. So this is, for instance, like they call this like position 1, 1. It's the first. Is it row column, Jeff? Is it RC? I think it is, right? You can have fractions in the radicals, totally. Yeah, RC cola, nice, cool. Yeah. Okay, yeah.
My man.
Yeah. So this is position 1, 1. So that means like the first row is like top to bottom, and then it's also the first column. And so we're going to take 1, 1 from this matrix and then add it to 1, 1 of this matrix and have it equal to 1, 1 of this matrix. Yes, exactly, Drew. Yeah, you know, I'll show you something more complicated when we start multiplying them. So yeah, this is 3x minus 4 is equal to negative 16. So that's an equation. Yeah, that's all you're doing. Now, by the same token, let's find, we could do this one as well. Let's do this one, and this one, right? That's going to be row 2, column 1. So that's 2, 1, which is the same thing as this, 2, 1, which is the same thing as this, 2, 1. They do. For addition, Drew, they do. If we start multiplying things, they don't. Then they do all sorts of weird stuff. So this was doing the 1, 1 position is what we got. Now if we do the 2, 1 position, -8, no. Yeah, we don't deal with -8 somewhere else right now. This gets us -1 plus -7, so -7. Oh, -8 is equal to y. Yeah. You're right there. And then this is equals to y. Yeah, I thought he was dealing with this -8. Yeah. Okay. Cool. And I think you were just trying to solve for x and y, right? So we only really need an equation that has x, and we just need an equation that has y, and then we're done. So from this, yes, -1 minus 7 is -8. So that just tells you that y is equal to -8. And then from this one, if you add 4, you get -12. So 3x is -12. That means x is equal to -4. Right? There you go. And that's your solution to your system matrix thing you made. Now we can do something harder. I can show you how to multiply matrices. Multiplying matrices are a little bit trickier. Yeah, you're welcome, Taco. Maybe you learned something here, Drew. If we talk about like multiplying matrices, let me get an example question. So yeah, for simple arithmetic stuff like adding matrices, subtracting matrices, you just make sure all the positions line up when you do stuff. We learned multiplying is next lesson. I'm gonna do it right now. This is kind of the cool thing. Yeah, here we go. I like how they actually animate this. This is kind of cool. But you can submit a multiplying question next time if you want, Taco. We can do that tomorrow. But I'll go over it right now. Example. Let me get an example here. Then talk about eigenvalues and determinants. No, don't scare them too fast here, man.
Wait, what are eigenvalues though? I know determinants, but like, what is an eigenvalue?
Eigenvalue is it's called like a steady state, I think is what it's called, kind of. Yeah, eigenvalues are weirder. Okay. That's an advanced property of matrices. We can get into later. Let's talk about multiplying matrices first.
Hopefully, I'll learn that too. Hopefully, I'll learn that.
Okay, so this was adding matrices, right? This was how we adding matrices. You can also do things where, for instance, you can say multiplying matrices by a constant. Let's say like by a number, okay? An eigenvector is a vector that remains the same direction after being multiplied, but ignore me. Yeah. Yeah, we'll get into that. It's a little bit more complicated, and you have to have a little bit more appreciation for matrices before eigenvectors start like making sense. You have to have an appreciation for vectors, really. Let's say you have a vector. A matrix that looks like this: 3, 6, 0, 2, 1, 4. Okay, and let's say that this is equal to matrix A. That's how they write this, matrix A. If I wanted to, for instance, multiply this by a number, let's say, for instance, I want to do 3 times matrix A, okay? That's the same thing as just putting a 3 outside of this, and then having the 3 multiply everything inside. And I'll show you like why that works, okay? So this ends up getting you, right, 9, 18, 0, 6, 3, 12. Okay, so that's multiplying a regular number. This is technically called a scalar. Scalar means it doesn't have like dimensions and stuff to it. It's just a number. It is like the distributive property. And you could see that this is also the same thing, right? As, let's say like matrix A plus matrix A plus matrix A, right? That would be the same thing as 3 times matrix A. And if you were to take this, for instance, we did one, but it was a 1 matrix plus a scalar. No. This was a matrix plus a matrix equals a matrix. No scalars. Scalars are single numbers. But yeah, so watch what happens. So if you were to, for instance, just add all these together, right? Remember from our rule before, right? Adding matrices, that I'm just going to like make sure it's the same position that I add up, okay? So this would end up getting you, right? 3 plus 3 plus 3, which is 9. And then 6 plus 6 plus 6, which is 18. 0, 6, 3, and 12. Oh, you're getting dinner? What'd you get for food? Lily, what'd you bring us? What'd you bring the class? You have to share. I made some, what did I make today? Tacos. Ooh, I like tacos. Yeah, I actually made some, like, breakfast tacos. I probably got a picture of it somewhere. I'll go find it one sec for you guys in a bit. I made some breakfast tacos today. Only 3. I do like one big one. It's kind of like burrito. Anyways, yes, so this is how adding 3 matrices, again, is the same thing as multiplying a matrix by 3. That's a scalar, is how that works. Yeah. Nice. Okay. So, let's work on the next thing. Ooh, I'm going to show... Yeah. Here, look, this was a picture of my tacos. They're really good today. I'm a fan of... I like cilantro. Does cilantro taste like soap to you? I love cilantro. Some people, they say cilantro tastes like soap, but I think it's weird. What if you multiply by another matrix? Very good, Drew. That's what we're going to do next. So that was multiplying a matrix by a constant. Or I should have said by a constant or scalar, really. Matrix multiplication. Yeah, okay, so here's what happens. Okay, so here's the rule with matrix multiplication. Okay. So first of all, whenever you multiply a matrix A... Here, let me kind of show this works. They use kind of the same colors here. You don't have the bad cilantro gene? Oh, good. Bless. Bless. I don't know how I would live life without eating cilantro. If you do, let's say, matrix A times matrix B, there are some rules. So remember when we were adding matrices, we said that they had to have the same dimensions, right? You have to do a 2 by 2 plus a 2 by 2, and that will give you a 2 by 2. When you're multiplying matrices, okay, let's classify the size of these things, right? This has 1, 2, 3 rows and 2 columns. So I'm going to say this is a 3 by 2. Okay. And then this right here has 2 columns and 3 rows, and that's why we say it's a 2 by 3. Oh, you got another problem for me, HH? Cool, yeah, we'll go through it. When you multiply these two matrices together, you need to make sure that these numbers, the inner numbers, are the same. You need to make sure that this equals this. And then the resulting matrix that you get is going to be a... whatever this number is, the first number, so it's going to be a 3. Oh, it ends up being a 3 by 3. That's actually really cool. 3 by 3. So this is the rule for multiplication. You can only multiply if those numbers are the same. We say like inner numbers must be equal. And then your result is the outer numbers. And that's for the dimensions. That's just for like the size of what's happening, okay? Now, in order to go like with how this works, right? So I know this is going to produce a 3 by 3. You can't square matrix. You can, because that would be a 2 by 2 times a 2 by 2. Right? So if you had matrix A squared, that would be matrix A times matrix A. And so a 2 by 2 times a 2 by 2, well, these numbers match, and you just get another 2 by 2. There's also some, usually, if we do this sometimes means like magnitude squared, which really means like the determinant. Yeah. Yeah, you can only square a square matrix. Yes. So if you had a 3 by 2 squared, then you would get 3 by 2 times 3 by 2. Oh, I see what you're saying. You're right, Taylor. Yeah, this wouldn't work. Sorry. Yeah, you can only square a square matrix. Thank you, Jeff. Jeff's correct. Good job, Jeff. Good job, Jeff. Okay. So I know this is going to be... That's a good observation, Taylor. You're paying attention. Drew Taylor, yeah. I know this is going to be a 3 by 3, right? It's going to be a 1, 2, 3, 1, 2, 3, 1, 2, 3. It's going to have 3 entries. Now, to figure out what the entries are, you do this thing where like you go across a row and you go down a column. So what I'm going to do is I'm going to say this is going to multiply with this. And really how it works is this is called like dot product multiplication, but I'll show you. So you end up taking like this number times this number. So that's 3 times 3. And then you add it to the next number times the next number. So the next number to the right times the next number down. So this ends up being times plus 4 times 6. And so that's 9 plus 24, which is going to be equal to 33. Or sorry, 33. So this number here then goes up in this position here, because you multiplied the first row. So row 1, and actually let me use the same color, sorry. Yeah. So row 1 times column 1, and that ends up getting you the position 1 comma 1 for your resulting matrix. Okay. So then, for instance, if I wanted to get this position, you just take this and you move it over. So here, I'll draw a separate one. I'm going to draw like here, right? Because this is like column 2. And you do the same thing. You do this times this. So here, I'm going to copy paste and just like start taking some numbers out. So instead of being 3 times 3, now it's 3 times 1 plus 4 times 9. Okay. And that's going to get you 39. And since that was row 1, column 2, okay, that's going to be this position. So 39. And that came from 1 comma 2. And then so forth and so forth. So like you go hit the next column, that gets you this one, and then you move this down to then get these, and then you move it down again to get these. That's how it works. Yeah, it's pretty wicked. It's pretty cool. I think they kind of show like there's like this animation of it as well. Showing, right? So if you like multiply all this by all this, you get this position. But then if you did like, say for instance, this times this, then you'd get that one. Let me go through chat real quick. The outer numbers have to be the amount of spaces because the first outer number is the number of rows and the second number is the number of columns. Yeah, exactly. Are eigenvalues the same concept as multiplicity, e.g. multiple roots of the same value in a polynomial? They're very similar. Yeah, they're very related, for sure. I mean, because eigenvalues are defined as values that satisfy like this equation. Here, I'm just gonna do a little quick little overview of it. So like eigenvalues. I believe it's determinant of like a minus lambda I is equal to 0. I think this is how you find eigenvalues. So it's kind of like the roots. So eigenvalues is determinant of, like, let's say the eigenvalues of matrix A is kind of like the values lambda such that A minus lambda I gets you 0. This is why we have calculators. Is that what you're saying? Yeah. What are matrices used for? Very good question. So anything in computer science uses a ton of matrices. AI is a ton of matrices. Machine learning, all matrices. Coding, the internet. The whole reason that like Google works is because of matrices. Because what happens is matrices are ways of like storing a lot of information in like these containers. And so sometimes these matrices can represent different things. Like they could represent the price of flowers in like city A, city B, and city C or something. And then this could say like how many flowers there are in each city or something. I don't know. Yeah, it's definitely data storage. It's also great for doing calculations amongst like really big populations of data. So for instance, the PageRank algorithm. Yes, graphics. Yes, yeah, Lily's exactly correct. So for instance, graphics deal a lot with things being in like 3-dimensional space, right? And you have to describe like where all the things are, and a matrix is a great way to show that. The PageRank algorithm, this is the original algorithm that made Google famous. I love telling students that like I was born before Google. They're like, what? No way. How were you born before Google? Yeah, Google wasn't invented until like 1999. But Google came up with the first way. So when the internet was first released, it was really difficult to find things. Like search engines like sucked. And then Google came out with this cool algorithm that what they do is they sort whether a web page is important based on how many other web pages reference it and what's the relative importance of those web pages that reference you. It's kind of like a popularity contest amongst websites. So if you have like a website on like turtles, and you have a bunch of really big like things such as, I don't know, museums and experts and blogs, and they're all referencing back to your website, Google would then see you as an authority on turtles. And then your web page would show up at the top. And the way to calculate that is to use matrices. What's up, Don? PageRank was revolutionary. It was. Yeah, it was. PageRank was so cool. Yeah, shout out to Don. Don's another awesome person that... Remember, I was telling you, Drew Taylor, I'm not the only person that like does math and science stuff on Twitch. Don does a lot of really awesome math stuff. He's actually going to grad school for math, I think, in a couple months, right? Month or two. And he does a lot of like self-study stuff in physics, all sorts of cool stuff. How big would a matrix be in Google? Massive. Massive matrices. Yeah. Starts in a month and a half. Coming up. Yep. It'll be here right before you know it, dude. It'll be here as soon, right before you know it. Yeah. That seems like a big websites get bigger kind of concept, because when people search for new info, they'll be directed to the big website instead of smaller potential web. Yeah. Well, it was an early way to identify credibility, because otherwise anybody could just write a website about nonsense. You know, I could start saying that the birds aren't real or something, which they're not. And if people started like Googling birds, right, and PageRank wasn't there, they would start thinking the birds aren't real. So PageRank was a way to like kind of enforce, not necessarily like big websites, but like authoritative websites. Because if a bunch of other websites like referenced you, you were probably legit. Yeah. So I mean that's nowadays PageRank is all out the window. PageRank is seen as like an archaic, like old way of sorting things. And I actually don't know. The algorithm is so complex these days. It's a lot of like AI stuff too and whatnot. It's funny. AI is really like killing the search algorithm game. Because people are no longer clicking on websites. So like for instance, if I wanted to learn about sea turtles, like let's just say like you did have to type the whole yeah, exactly. If I say like let's say like where are sea turtles found in Los Angeles, right? Let's just say I wanted to do this, yeah? Google now uses their AI stuff to give this AI overview, and people don't click the websites anymore. And this is bad for these website owners, because their information is usually funded by people clicking on their website, and then there being ads, right? So I would click on NPR, and then look, there's sponsored messages and stuff, and like people pay for these ads, and look, I don't, wait, where are my ads? Well, anyways, stuff like this. Yeah, here we go. Like public media. Yeah. All these ads is how like NPR provides this information on green sea turtles. But now Google's doing this thing where like people don't even go to the website anymore. They just watch the AI summary. Yeah.
That's what people are doing nowadays.
100%. And so it's actually it's a very interesting shift in how the internet, like, overnight is changing, because it used to be that when people wanted their websites to, like, get clicked on and stuff, they really prioritized having nice graphics, like cool pictures, like flashy descriptions, blah 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 blah, right? Nice aesthetics. Nowadays, people just want the information, and they want AI to be able to provide that for them instead of them clicking around and searching for it. And AI prefers language. It prefers text. It doesn't like graphics. That's extra work. It has to interpret shit. So it's this almost like complete 180 in how, like, information works, where now if you want your information to get, like, seen in front of people, you actually want to kind of dumb it down so that AI can interpret it, like, well. It's such a wild time to be alive these days, man. I don't know, like, what's going on.
That's crazy, to be honest.
It's crazy.
Like, I feel like okay. You remember how I said I would turn a new leaf in like college?
Yeah, I say the same thing like every week. Doesn't really work out.
I don't
Go on.
turn a new leaf in college. You said, right? You said that? Or...
No, I was joking that I say I'm always going to turn a new leaf like every weekend, but then, like, you know, same thing happens. But yes, go on.
No, like, you said do not turn a new leaf in college, but yeah, it's like whenever I do assignments now, it's like I would rather not have ChatGPT like do the work for me. It's not like as if I was relying on it.
No, use ChatGPT. You can use ChatGPT. ChatGPT is great. You should use it to verify your work, or if you're confused, get it to help explain things. Don't get it to do it for you. That's the key. You know?
But yeah, that's what I would do. But there will be those situations where it's like I would have like procrastinated or have little time, and then I wouldn't even be able to do the work.
There's the temptation there. There is a temptation there for sure.
Yeah, but I'm
that you're gonna be like,
I'm resisting. No, I'm resisting.
You're running out of time, and you just use ChatGPT to copy paste your homework. I mean, I did the same thing in college with friends. Like, sometimes I didn't have time to turn in my quantum homework, so I would just go to my friend Francisco, be like, "Yo, bro, can I see your homework?" And I would just copy it and turn it in. And then I didn't learn quantum. You can't use ChatGPT to check your work. Yeah, exactly, Drew. How will they enforce that? They can't. And this is what I say, like, rather than like try to come up with these dumb arbitrary rules that'll never be enforced and honestly only hurt the people that are honest, because everybody else is just gonna fucking do it. You just need to level the playing field and come up with new ways to, assess, maybe make homeworks worth less points, because homework is basically completion. Or like what I do with my UCLA class is I made the homework schedule pretty like intense. Like, there were 2 homeworks assigned every week, and they were due a week later. And I was pretty strict about deadlines, because to me, I was like, you can ChatGPT this and get it done instantly if you really need to. But I'm more or less now like testing on, do you have discipline to like set aside time to like complete your assignment? And that's the assessment that I now give. Yeah. A Jacobian, yeah, that's an extreme thing, India. Yeah, we'll go into like higher level matrices stuff at another point. But yeah, matrices are ways to store numbers. Yes. Okay, Ethan, you want to do some physics? We're gonna do some physics today. You want to do some physics too? Exactly, Lily. Yeah. This is. I'm gonna write a LinkedIn article on this. What you need to do, instead of like telling students they can't cheat, is explain to them why cheating is like cheating themselves. It's why it's harming them. You can't like tell kids like don't smoke vapes. They're just gonna do it. But if you tell kids like if you smoke vapes, your brain is gonna get small. I mean, they might think twice, right, about doing that. So it's, for me, that's kind of the thing with AI. It's like telling students, if you're using it to copy paste answers, you're shooting yourself in the foot, and you're not going to learn anything, and you're not going to get a job, and you're going to live at home, and like you'll never like live a life. And like if you really like scare them enough into this, then they'll start saying like, oh, I actually need to do the work and learn things. But I don't smoke or vape because it'll ruin my gains. Good. WHH. Did you send me a question, bro, by the way? Oh, you did. What'd you send me? Oh, more Fourier stuff? Oh, okay, cool. We'll do it next. Okay,
Is that
Ethan,
my-
you
is
want?
it my
Let's try
turn?
and do this one. Yeah, let's do yours, and then HHH. I'll do yours. Okay. A block is held at rest against a compressed spring at point A at the top of a frictionless track of height h. The block is released, loses contact with the spring at point B, and then slides along the track until it passes point C. Also at height h, how does the potential energy of the block Earth system and the kinetic energy of the block at C compare to point A? That's cool. Okay. So there's like 3 conditions here.
And potential energy.
Okay. The toughest JEE question? I don't want to do that, Shivram. JEE is mean, dude. JEE is for, like, scaring people into never doing physics.
Oh gosh.
I understand why they have it. They have it because you have too many people in India trying to, like, escape poverty. And so they have to make some, like, ridiculously hard test to see who, like, really wants it. But for, you know, the rest of the people that aren't like dealing with that, it's just nightmare hard. It's not even fun. Okay, so let's consider Ethan. We're gonna talk about like conservation of energy. So here, Ethan, right? We have a block that is compressed against a spring at point A. Okay. And it's like it's being held. Do you see it? It's being held at rest. Okay. All right, cool, nice. HOI 4. What's that? Heroes of something. Here, what's HOI 4? Okay. Yeah, let's talk about like energy. So there's a bunch of different types of energy. What are some energy types that you know about? Oh, hearts of iron. Oh, okay, I don't know that one.
Different types of energy.
Yeah, hearts of energy.
Okay. Well, there is.
Sorry. What type? Sorry, hearts of energy. Sorry, it's hearts of iron. What types of energy are there? So I'm getting confused.
Well, there is mechanical energy.
There is mechanical energy. Yeah. So that includes what we're gonna call as like kinetic, and in this case, yeah, that's it, just kinetic. And then we're gonna have gravitational potential. And we're gonna have spring potential.
Alright.
Ooh, I love RTSs. And World War II is great. Yeah. I mean, as a video game like environment, it's really fun. Okay. So if this thing is being held at rest, Ethan, what's the kinetic energy at the blue state?
At the blue state, is it just 0 because
Yes.
there's no movement or motion?
Yes, it's 0 because it's not moving, right? So this is like 1/2 mv squared. This is mgh, and then this is 1/2 k squared. RTSs, I played a lot of Age of Mythology back in the day. A lot of Command and Conquer, right? Red Alert 2. A lot of StarCraft. I don't know if I've played any real modern ones. I think StarCraft 2 is probably the most modern one I've played. No, you're okay. I like the banter. Okay, what's the gravitational potential? Yeah, right?
Yep.
That's going to be equal to
Gravitational
mgh.
potential, yeah, mgh, because I mean it is up high.
It is up at a height, right? mgh, yeah, great. Okay. And then it's going to have a lot of spring energy, right? Because this is compressed. And this is going to be 1/2 kx squared. Don, you know what we should do, man? We should do a StarCraft 2 like stream or something where like I just try to remember how to play StarCraft. What's up, 1K? It was super fun. Okay, now let's look at position B. All right, energy. Okay. Let's talk about like the kinetic. What's the kinetic going to be?
Kinetic. So, well, I mean, wouldn't it? There would be movement, but
There would be movement.
I do not know how to say.
So you can just say this would be
Well, what
1/2
kind of-
mv squared. We don't know what the velocity is, but
Really?
it would be 1/2 mv squared.
Oh yeah, for sure, yeah.
Don, what faction do you play? I was always Marines, Space Marines, or Terran. Sorry, they're called Terran. I'm used to 40k lingo. Okay, gravitational here, Ethan. Right, still MGH.
Yeah, it's still MGH. And the spring potential is
What's the
it
spring
somewhat half
potential?
px squared?
No, it's 0.
And why
Because-
is so? Because it
Because
was just by the
once
spring.
the thing has left to position B, it's no longer attached to the spring. And then see here it says it loses contact with the spring at point B. We assume that the spring is uncompressed at that point.
All right,
Zerg. Oh my God, Don. All right, I know how to defend against the Zerg rush for you, Don, dude. I gotta get a bunker up real quick. Okay, let's look here at position C. So let's do like an in between position here, just for funsies, because I want like so this thing is. One sec, let me get a picture of this. This thing is gonna be compressed. It's gonna shoot out, and then it's gonna like fall down here, and then it's gonna come all the way back up. Okay. Let's consider when it's like right here. Let's say this is like position D or whatever. Okay, because I want to show something about how the energy works. So here, this would definitely have kinetic, right?
A lot.
We could say this is
It would
1/2
definitely
m. Let's say
MV
VD squared. VD squared tells me that it's the velocity at D.
All right.
You should be a teacher. You should be a tutor. Oh, I do tutor as well. I definitely tutor. I tutor a lot. I'm a tutor, a teacher, a person. But what's gravitational energy here?
Yeah, definitely, that's obvious. That's 0. There's no
0.
potential. There's no height in this.
Because it's at the ground.
It's absolute.
Cool.
What if I said absolute 0? Would that make a difference?
No, just
Because
say
they
0.
do have-
Don't say absolute 0. Absolute 0 is something in like chemistry. It has to do with particles being so cold that they don't vibrate anymore. Yeah, you're not at absolute 0. You're not at absolute 0. Okay. Cool. So there's something cool here. By conservation of energy. Conservation
of energy.
What does that mean,
Is it
Ethan?
like-
Conservation
wait.
of energy.
Well, there's 2 of them. 2 laws of conservation of energy. The first one, which I'm still confused with, energy can never be created nor destroyed. That's the most obvious one.
Howdy, Illy. Yeah, energy can't be created or destroyed. It can only be like converted, transferred.
Yeah.
Yes,
But then
absolute
the
0
next
is the
one, like
absence
you
of all
just said-
energy.
Yeah.
The other one is
the-
that the total energy is constant, right?
I mean, I think it went something like this, where one form of energy is transferred to another form of energy.
Good.
Is it that?
Yeah. And these are kind of like all the different
Okay.
forms of energy, right? So
All right.
what we end up saying, Ethan, is right, like this is going to be sum total, right? And that has to equal the same total as this, which has to equal the same total as this, which eventually has to equal the same total as this one, which, you know, this is kind of going to be the same, right? Kinetic is 1/2 mvc squared. Potential or gravitational is mgh. It's the same h, and then spring is equal to 0. But that total also needs to be the same as all the other totals. Okay.
Yeah.
So here's a good question, Ethan. When is this thing going to be the fastest? When is the block going to be moving the fastest?
All right. Well, like if you're just talking about this image,
Oh, what's up,
I
Lily?
would think it would be fastest. I think it would be fastest at B, because I mean, like,
At which
it's
point?
starting to gain that much. B.
B? You think it fastest at B?
I mean,
As-
yeah. Because
okay.
it's starting to get.
So I agree it'll be faster at B than it is at A, right? Because at A it's 0. and then at B it has like some kinetic, right? Because what happened is this spring energy here got transferred in to kinetic energy, okay? So you're right, this does have kinetic energy. And kinetic energy is related to velocity, so it must be moving, and that means that, yes, it is faster at B. But look what happens when it starts falling down to D. Look what happens when it falls down to D. What about the other energy terms here? Do you see how there's 0 gravitational now? And there's 0 spring?
Yeah, I mean, I forget that gravitational can convert to kinetic and vice versa.
Correct. Yeah, it's a conservative like energy thing. So this gravitational energy here now got dumped into kinetic. It got converted. Because again, remember, all of this has to add up to a big number. All of this has to add up to a big number. But none of this is anything, right? Gravitational is 0. Spring is 0. So this whole big total is all of this. Which means the velocity here is going to be bigger than the velocity here. Yeah?
Yeah, I understand now. I see that.
Okay, good.
Yep.
Right, so that's why it's the fastest there. And then if we look between position, because they want us to talk about compare position C to position A. Okay. So let's maybe compare position C to position B. What can I say about this one versus this one?
Well, they're the exact same.
Yes. Why are they the exact same?
They have no spring energy.
No
they
spring
have
energy.
The same gravitational.
Same gravitational energy. Good.
And this kinetic energy is still the same.
So the kinetic energy has to be the same because all of this has to add up to the same thing. So if the spring is gone, and this is the same as this, then this must also equal this for all of this to add up to all of this. Yeah. Okay. So that tells me that everything at C is the same as at B. And so now we can talk about between position A and position B, really, instead of position A and position C. We know, okay, interesting, the potential energy. Now here's a good question. When they say potential energy, I think they're also including the spring.
Would think.
Yeah, because spring is a potential. Spring energy is a potential energy. See how I said spring potential? So I think when they say potential energy, they're not they don't mean just the gravitational potential energy. So which one of these has more potential energy? At position A or at position B?
I would think at A.
A, right? Because they have the same gravitational, but A also has spring. So I would say that UC is greater than UA, right? So these ones are not right. We don't care about these.
I actually thought I have the answer. I actually have the answer.
Okay. Well, let's get to the answer first. Okay. Is the answer UC equals UA?
Yeah.
Okay, so then they're not including the spring. So, okay, they said potential energy of the block Earth system. I assume when they say the block, they talk about the spring attached to the block. But I guess if this would have to also be the spring for me to be thinking what I'm thinking. Okay. So, if they're just referring to the gravitational potential energy, which I guess it makes sense, because they're talking about the potential energy between the block and the Earth. Gravitational potential energy arises because the Earth wants to pull things towards it by the force of gravity. So if you have things away from it, you're creating potential. You're creating energy that can be converted into kinetic if you let go of it. That's how this kind of works, I guess. Yeah. Okay.
I understand.
Cool. All right. So yeah. All right. So they're actually the same. Whatever. This is wrong. Okay.
Yeah,
kinetic energy. Well, we know kinetic energy at A is what compared to the kinetic energy at C?
They're equal. It says it down there.
It says they're equal?
You're talking about up there. No. I'm just saying. No, wait, hold on. Like, if you're referring to up there, then you would say that kinetic energy of A is, well, like
Kinetic
less
energy of
than
A
C
is
because it's
0.
actually-
Kinetic energy of A is 0, Ethan, right? You see that?
so it's less than whatever C is.
Good.
If it is just,
Good job.
even if
Yes.
it's just like, even if it were to just be 0.1 energy, then it'd still be greater. But less,
Yes.
sorry, it'd still be less than.
Yes. Okay. Is the correct answer B?
Yep.
Nice. Good job.
I think I could have done this by myself.
You think you could have done this one yourself? I mean, maybe.
Yeah, like
I hope you could. I mean, that's the point of learning. If you could do it by yourself, that'd be sick. All right, let's see. HHH is giving me like hard ones here. What classes are you in HHH, by the way, dog? Is it annoying that it considered UA equal to UC? I think it is, but I think Lily, it's because when they talk about U, they say it's the potential energy of specifically the block Earth system. They're not talking about the spring as well.
No.
That's like a tiny little detail that's annoying to deal with. It is annoying.
I wanted to say two things.
What do you want to say?
Did you ever give out like the credit for asking the questions last week?
I did. I'm pretty sure I gave you credit.
Okay. And I mean, what would you have said weekly question thing you said?
Yeah, I'll do weekly questions.
At the end of the week, right? At the end of the week?
Yes, end of the week I'll talk about it.
I
Helen
hate
says,
that you
hello,
did, I
coach.
see it.
I hope
Hello?
I'll gain and learn something. Nice. Okay. Yeah, that's the other nice thing about me, like, not teaching at UCLA now for the rest of the summer is I have more free time to do things in the Discord with you guys. So we will do more things.
Yep. And thankfully.
Like,
But,
we'll talk about the sea
there's
turtles,
two more
apparently.
things. There's two more things.
What's up?
I just want.
Yeah, Lily. Yeah.
Did you ever take a look at my DMs? Like I told you for Sunday.
No, maybe not. Something about you did all the kudu assignments. I think you told me that at one moment. I've been grading final exams a lot for the last couple days, so I haven't really had much time to check all my DMs.
Oh well, I mean, I don't know if you will believe it, but
Yeah.
well, I'm not saying it, but you might not believe what I did, but I have the proof right there.
Okay, I'll go check it out. I'll check it out later.
And we have only 2 weeks of this little SCP tournament, right?
Yeah, we got about 2 weeks. Yeah, two and some
Do you
change.
think I could even cut? You think like within 2 weeks I could get the best chance, which is first place?
Maybe. We have a talent show. We're gonna do a talent show as well. I love the talent show. Talent show's my favorite.
I hate it.
I love the talent show.
I have never participated in one. I have never participated in one.
Might be time to. Okay. Let me try to do this question from HHHHH. He says, I'm taking a Diffie Q as my summer course right now. I start my electrical engineering course in the fall. Okay, cool. Consider the function f of x is cosine of x, and it's defined from 0 to pi over 2. I'm going to just graph that real quick, just because I know what cosine of x looks like. I think it's ECE, right? Is that electrical engineering? Good luck, man of many H's. Lily's wishing you good luck, man of many H's. Okay, this is going to be pi over 2. Cosine x starts at 1, right? And then ends at -1, yeah? Wait, no. Fuck, that's at pi. It just does this. Yeah. Or, I mean, I can probably, like, draw it a little bit better. Zero for pi over 2. Thanks, Jeff. Good. Sketch 3 periods of the odd pi periodic extension of f of x. I have no clue what these words mean. What does this mean? I mean, I know what odd means. Odd means that f of negative x is equal to negative f of x, which cosine is not odd. Cosine is even. Right? Does that mean I'm well, okay, they said pi periodic. So I assume that means, yeah, it would be discontinuous, right? Yeah, exactly. If I want something to be periodic in terms of pi, that means I need to extend it out to here, right? Negative pi over 2. But then if it's odd, right? I need, like, going this way with positive values to get me negative values as I go the other way. So this is going to look something like this, I think. Make cosine odd by adding a period of pi. Is that what it's asking? I think so, Jokes. I'm actually not entirely sure, honestly. I mean, it's kind of a weird question. I've never seen this question before, but it's okay. It happens sometimes. ChatGPT? Yeah, I mean, we could use ChatGPT for it, but... And I probably will honestly get to that, because I don't know what this means. This is something that probably got defined in some obscure fucking, like, lecture from a professor, and now they're expecting you to do it for homework. But I assure you that I have not seen that as, like, a formal thing. Okay. This is periodic in pi, and it is odd. So, to me, that seems okay. Right? So if I wanted to make it periodic again, I think this is just what I do, right? Here, let's get rid of these labels. This is -1. The free version of ChatGPT is so bad. It's not too bad. It's decent. I agree. You should. Okay, here we go. So this would be pi, right, to 3 pi over 2. And I think this would then be... Let me get rid of this. This would be the third period, yeah? Because then that'd be 4 pi over 2, and this would be 5 pi over 2, yeah? Okay. Find the Fourier series for this. Oh, okay. Okay. I need to, like, kind of Google some stuff. Fourier series. For sine. Integrate cosine n theta f theta from minus pi over 2 to pi over 2. Here. I like Paul's online math notes. He's a pretty decent dude. Okay, where is it? Okay, here we go. Okay, here we go. This is what I want. I'm pretty sure this is what I want. I don't think I need to integrate it. Look at the Fourier cosine series. Okay. Good old Wolfram. Daddy Steven. Okay. But this is an even function. But we want an odd function, Jeff. Paul is love, Paul is life. I do like Paul. I think I want a Fourier sine series. I think I want this because it's an odd function. And then this is what we get. Yeah. Never listen to me. No, you're good, Jeff. You're good, dude. I mean, I think Paul has the simplification, but Wolfram is kind of a more complete way to do it. And this is where B of n is equal to this. And if you let the range go to L, but I don't want it from 0 to L. I want it from negative pi over 2 to pi over 2. Right? So I'm tempted to do it this way. I mean, I guess it's kind of the same, right? Okay. Okay, so in this case, L is equal to pi over 2, right? Because we're going from negative pi over 2 to pi over 2. And then, let's see what else Paul says. Where's my boy Paul, dude? There you go. And where's the expression for B? Oh, and then here's for the coefficients. Yeah, okay. Maybe split the bound and then do it algebraically. Yeah. Like, you're saying go from 0 to pi over 2 and then just, like, alternate it? Okay. I think this is the summary. This is just one of these things. Again, we could go through and rederive why all this is. And I 100% recommend that you go through it. I just, for the sake of the stream, I'm not going to do all of it. And also, this is what you should be, like, learning in whatever class you're taking. But okay. I'm going to use Paul. I like Paul. There we go. This is what we have, right? Okay. So we're going to be going from L is equal to pi over 2. And then that means that f of x is going to equal to the sum n equals 1 to infinity. Do I want to do it for just 3 periods? Oh, no. It's for, like, infinite, right? This just, like, keeps going on forever. Oh, wow. Okay. And then this is going to be b of n sine n pi x over pi over 2. Pi's are going to cancel. So you get sine of 2... Sine of 2nx, right? Okay. I think that's okay. And then we got to define what b of n is. So then b of n is equal to... Okay, and then here's the odd thing they say. Yeah, look. So instead of doing from negative L to L, because... sine is odd. I thought you can only do this if you're integrating cosine. Right? Yeah, negative L to L is only equal to 2 times 0 to L if what you're integrating is even. Huh. Okay, well, you know, I'm sure Paul has a reason why it is, but let's trust Paul. I'm going to say 2 over pi over 2, and it'll go from 0, pi over 2, and then f of x, which is cosine of x. Oh, sorry. F of x is, sorry, sine is odd, cosine is even. Wait, but we just made it odd periodic. Oh, this is blowing my mind. Wait, what? What? Cosine is an even function, but we made it odd periodic by doing this like discontinuity thing. So really we just created, I think I see. Okay. I see, because it's built in. Okay, if this is the function f of x is equal to cosine of x for 0 between x and pi over 2, right? But then it's equal to negative cosine of x for 0, sorry, between negative pi over 2 x and 0. Okay, I see. And so because that minus sign is going to come out here, this effectively, yeah, this makes it an odd function, even though it used to be even. Okay. I think I see. Okay. That's going to be cosine of x and then it's going to be sine of 2nx dx. Yeah. This is not an easy integral to do because you have a double angle formula here, right? How doth thou do this integral, though? Cosine x sine of 2nx. Alright, fuck it. I'm going to ask ChatGPT. I just don't want to do the double angle. Integrate this. Oh, I see. They're gonna use a product of sum identity. Jesus Christ, H, dude. Like, what? Why does your teacher do this to you? Okay, cool. All right, we're gonna use this identity. Again, this is what I talk about, like using ChatGPT intelligently. I could just plug your whole question into ChatGPT and just tell it to fucking give me the answer, but we wouldn't learn anything. So we use it like selectively to break down roadblocks. Like we use some Paul math notes to figure this out. And then we get to an integral, and this integral sucks. But oh look, it looks like this. So this is gonna be the same thing as 1/2 sine of x plus 2n x minus sine of x minus 2nx. Use integration by parts. You can't exactly because it will you can't because the arguments are different. This has an nx in it, Shivram, and this only has an x. So that's going to cause a lot of issues if we start doing integration by parts, because this will just keep oscillating back and forth. Maybe you could do it by integration by parts, because you're going to choose one thing to integrate, one thing to derive, and you're going to hope you get the same thing, maybe. Actually, let's just try that. Actually, Shiverum, you have a good idea. Let me try that. I'm tempted not to because of the different arguments, but it might work. Sine of 2nx dx. Okay, I'm going to call this thing u. So that means du is equal to negative sine x dx. And then I'm going to call dv is equal to sine 2nx dx. So then that means v is going to be negative 1 over 2n cosine of 2nx dx, right? That's the correct way to do integration by parts, right? It's like a reverse chain rule type thing. Yeah, okay, cool. So then that's equal to uv. So that's going to be negative 1 over 2n cosine of x cosine of 2nx. Oh, sorry, there's no dx here anymore. Minus the integral minus, that's positive, of 1 over 2n. And we're going to say sine of x cosine of 2nx, right? dx. Okay. Now I go into here. I choose this to be my u. Yeah, Nick, I'll do yours after this. Du is equal to cosine x dx. This is just becoming a pain. Can we say that cosine x equals negative sine x minus pi over 2 so that the arguments are opposite reciprocals? Perpendicular slopes? It might. Yeah, wait. So dv is cosine 2nx dx. So that means v is equal to 1 over 2n sine of 2nx dx, right? I do that right? Yeah, okay. So then here's the cool thing. Then that becomes, so minus 1 over 2n. And that becomes 1 over 2n. Sorry, there's no dx here. Sine of x. Sine of 2nx. Minus the integral 1 over 2n of cosine x sine of 2nx dx. Okay. And then this is a cyclical thing. So if I bring this down as well, this is all equal to my original integral, which is cool. Because this thing shows up here as well. The issue is like there's a fucking mess of all these coefficients. Okay, so let's try to like simplify it out. So I'm just gonna say negative 1 over 2n, and we're gonna say like cosine x cosine 2nx minus 1 over 2n sine of x sine of 2nx, and then okay, so I pulled that out of that. And then finally 1 over oh, you did in Zach's series class. Oh, see? Where's Zach? Zach, where are you at? It is tedious. I agree. But it builds character. Thankfully, I have copy paste. Okay. So now I can bring this over, right? And so I'll get integral of cosine of x sine of 2nx dx times 1 minus 1 over 4n squared is equal to all this. And then you could technically divide this over. But that is ugly as fuck, dude. What? No. That's so ugly. That's a big pile of shit.
Big pile of shit.
It's a real big pile of shit, yeah. Okay. I mean, this is a cool technique to know, regardless. I mean, I'm glad that Chevron, like, brought it up. This is called, like, cyclical integration by parts, where eventually, if you do integration by parts twice, you get your same integral back. And then you can, like, kind of try to isolate for it. And then, like, you're moving this over, and then you're dividing it by it again, and you get this. This is gross. Okay, fuck this. Oh, man. I'm just going to leave this as an exercise to the reader. And I'm just going to calculate this integral. Because this is just going to be 4 over pi. Integration sucks. I think it's fun. Like, there's definitely some fun patterns you can do. Come up with the... And this... So this is kind of a... I don't trust ChatGPT to do the integral exactly correctly. So I'm going to tell it to give me the code. Then I'm going to go to Wolfram. And I'm going to notice that this is already wrong. This should be 4 over pi. Cosine x is 0, good. And then let it rip. Yep, that's my integral. Okay. And we could click a step-by-step solution if I wanted to, but I'm not going to. So there you go. That is the result. Whoa, no, not all that. Cool. Okay. So then f of x just equals the sum from n equals 1 to infinity of... why is this rotated? Of this thing. And then it's times sine of 2nx. Does any of that simplify out? Well, sine of pi n is 0, right? So I think this goes away. Right? We assume n is an integer. I can't remove this because I don't know what x is, right? X can be part, like... So this is n equals 1 to infinity. And that's going to be 8n over pi 4n squared minus 1. Sine of 2nx. 8's are going to cancel. So n equals 1 to infinity. Sine 2nx over 4n squared minus 1. I think that's what it is. Yeah. What about the sub-zero term? Oh, it's 8 pi? Oh, you're so right. Sorry. Wait, why did I write an 8 there? Oh, yeah. Sorry, I don't know why I canceled the 8 there. That's wrong. Thank you. Sorry. That's... (8n over pi). Yeah, okay. It looks a bit harmonic, yeah. Okay, let's see if I were to throw this into ChatGPT, what it would do. I'm just curious. This is kind of like, yeah, testing a little bit of the upper levels of... This isn't really Diffie Q, man. This is advanced. Does Paul think this is Diffie Q? What does Paul think? Oh, Paul does think it's Diffie Q, but like, this is like the end of Diffie Q. Let's throw the heavy ChatGPT on it. Let's see what we get. Two pi x to be 2 pi x as sine is a small angle. Well, we don't know if it's a small angle, right? It goes from negative pi over 2 to pi over 2, so it's definitely not small. Let's see what ChatGPT can do. Causing it to struggle. Ooh, 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 ooh. Look, 8k over pi 4k squared minus 1. That looks pretty close to what we had, no? 8k over pi 4k squared minus 1. Yeah, fuck. Yeah, right, look at that. That's cool.
Good job.
Yeah, that relation is that Fourier series pops out from the heat equation. Okay, here we go. So let's see. So, okay. They define it on 0 to L to be cosine, and then from negative L to 0. Oh, but L is pi over 2. Okay, great. Awesome. Cool. I don't know exactly what's going on here. This looks very similar. Right? Oh, here. Final result. I think this is the same thing we had. Yeah, that looks pretty damn good. Yeah, hell yeah, dude. Fuck yeah, we did it. Wow.
Damn, man, look at that. Look.
Wow, look at that. Okay. Wow, that's pretty dope. Okay. I don't know exactly why that happens, but we did get the right answer. So that's something where, I don't know, when I started getting to those topics in some of my math classes, I kind of just learned procedurally, like, how does this thing work? It was 8n over pi, yeah. Yeah, ChatGPT said 8n over pi. Which, again, I just did it from here. I really just used... This is all we really did. We just did this. But then I used, like, Wolfram Alpha to do this integral, because this is an ugly piece of shit. And then we recognize that sine of pi n is always going to be 0. And you simplify down. And you get to it. And that's what chat says. I kind of trust the hybrid approach of, like, listening to Paul talking to like Daddy Wolfram and then getting the same answer as chat. Like, the chance that all three of those things are wrong, very, 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 very small. And yeah, I'm unfortunately not a master in like Fourier series. Well, not like Fourier sine series. I know how like a Fourier series works, but calculating them, that's ugly. Ugly. Yuck. Yes, exactly. Dawn, the Holy Trinity, the Wolfram, the GPT, and the Paul. Amen. 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 We hit the Holy Trinity of math. I do like Paul. Who is Paul, by the way, dude? Do we know is he a professor somewhere? Paul's math notes. I used a lot of Paul's math notes back in my day. Type shit. Yeah, exactly. Type shit. Wait, who? Paul Dawkins. Let's go find this guy. University of Texas at Arlington. Yeah. This is him. He looks like a math guy, for sure. Those glasses are pretty boss. Investigating students' moment mathematical proof. Yeah, cool. Yeah, this dude needs a fucking medal, dude. Holy unks, yeah. He's a cool guy. Yeah, so, yeah, if you ever want to, like, if you're ever getting, like, if your textbook sucks and you're not understanding how to do things, Paul here, his math notes, he's written on pretty much everything from, like, I would say lower division math to a little bit of upper division. Calculus, math, whatever, Diffie-Q stuff. So, and look, he's got cheat sheets. Yeah. Yeah, look at this. He's got a calculus cheat sheet. Let's see this. Look at this. This beautiful ass cheat sheet he's got. Yeah. Common derivatives, chain rule variants. This is cool. Yeah, he's showing how like different chain rules, higher order derivatives, implicit. He even shows like an example of it. Yeah. How to do, yeah, Extrema. He has like a related rates cheat sheet. This is really cool. Yeah, no, the guy's a G. There's so much information out there. You just have to like kind of know who the good ones are. This is where the Google PageRank algorithm comes in handy. Okay. Nick, let's finish off helping you out with some court officer questions. I gotta go find you. You're down in my chat somewhere, Nick. Where are you at? Here, send me a DM real quick because I have my chat is so far down. Just send me a DM real quick so it pops to the front.
Okay.
Nice. Let's see. Talk about the AMC 12. What's the AMC 12? Is that like a new movie theater? Mannersy says, how are you, man? Watched the live stream 1 to 2 weeks ago. Wanted to tune in next time, but didn't have time. Nice. Thanks for coming by. Yeah, if you ever want to know, like, so we have a pretty regular streaming schedule, and there are a couple other people that are our, like, friends, partners that do math and whatever streaming. But if you ever want to check out the calendar, here, I'll send it to you guys. That's the calendar right there. Interesting streaming idea. Yeah, we help people out with just like math, science questions, whatever. We reward students with like video game gift cards for like doing well in their classes and stuff. But we have a calendar here, so I'll be streaming again tomorrow at 5 o'clock, and then our friend Zach, E2iPie, is gonna be doing a stream at like noon. So check out that calendar. Zach should put in his. Does he not put in his Twitch address? He really should. But let me get you Zach's Twitch as well. There you go. So he does a lot of really cool stuff, Zach. Recently just got his PhD in math, and he explores a variety of like higher level math topics than I'm like comfortable with teaching. my PhD's in physics, and while I am pretty confident in like tutoring up to like Diffie Q, I say for the higher level math stuff like discrete or topology or like whatever, go check out Zach. He knows more than I do in math. Okay, but let's help you out. Nick, which one do you want to start? Which one you want to start with? What did we do last time?
The forcible rape stuff.
Forcible rape. God damn it. Wait, did we do that? No. We already did that question. The property crime and the robberies. Yeah, we already did that. Okay, we're gonna do these. Yeah. So a little background. Nick's been in our server for probably close to 5 years at this point. And he graduated from high school, and now he's looking at applying to some jobs. And one of those jobs is being a court officer, which requires him to take like a court officer exam, which it's very funny to work through this. I love seeing what these like standardized government exams are. They're an absolute hoot. So here we go. They involve like crime. That's why he was saying like forcible rapes. Like that's like a crime statistic apparently.
Yeah.
Gives me a stroke. Yeah, it's not all topology, not Raven. I'm just saying if you want to talk about topology, he can do it. Zach tends to actually do like really cool. He does game development too. He's creating like a trivia type game for all sorts of STEM subjects, and it's like an online kind of like a Jackbox thing. And so sometimes he'll go over like how he codes that live on a stream, and he also he'll do like fun little puzzle questions. People will come up with like little math puzzles, and he's good at doing those as well. Okay, let's see. In 1995, the daily cost per inmate in the Jackson Correctional Facility was... Okay. Well, this is 2000. This is 1995. Okay. So, do you see how they're testing you on like if you know what fucking table to look at? So 1995 is table A, and daily cost per inmate. So in Jackson, we don't have that. Okay. How does that work? Let's see how this number works. Okay. Daily cost per inmate. All right, one sec. Assume that Perryville contains 5 jurisdictions. Assume there are 365 days in a year. Assume that the number of inmates does not change. 365 days is 1995. 366 is 2000. Ooh. Okay, so cost per inmate, right? Daily cost. Okay. So that's going to be dollars per inmate. Okay. And let's see what we have. We have a yearly budget of in what county? In Jackson County of 182,500. So I'm going to say 182,500. And since that's a yearly budget, that's like per year. Okay? So I want to figure out, I want like inmates per day. I want daily cost. I think I want this per inmate per day. Well, whatever. Okay. Let's figure out dollars per day, and then we'll just divide by inmates. Yeah. Okay. So you have to do that. 1 year is 365 days. This cancels out. So then we pull out our calculator, and I'm going to do 182,500 divided by 365. Good. So that's 500 bucks. 500 bucks per day. Okay, but then how many inmates do we have? We got 100. Okay. So that's going to be $5 per inmate then, right? $500 divided by 100 inmates. It's $5 per inmate.
I did 182,500 divided by 52 and then by 7.
That works too. It's not as accurate though, Nick, because there's not exactly 52 weeks in a year, right?
Yeah.
Yeah. Wait, right? Am I crazy? Sorry. 52 times 7. Yeah, it's 364. Yeah, you lose the leap day kind of tech thing.
Hey.
Pretty good rent. Yeah. What, $5 per day for an inmate? Yeah, that's pretty cheap, dude. Right? It's only $150. That's really cheap rent. Damn. And they get them to like make like license plates. It's actually kind of a profitable business, the incarceration system we have here, with a meal plan
and dental plan.
Yeah, who wants to go commit some crime, dude? Like, let's go do it.
Free rent, free medical, food, gym.
You do get a gym.
It's insane.
You just might, become somebody's like, jail wife at some point. You don't want that to happen. Okay.
I wondered how you gonna say that.
I know. I wasn't gonna go into forcible rapes.
Surprise, motherfucker.
Okay. The total number of inmates at all 5 of Perryville's institutions was 865 in 1995. Okay. The total number of personnel. Oh, okay.
The ratio thinking.
They added this for us here. Oh, okay. This is actually pretty interesting. So they say the total here is 865, right? So we have to figure out how many are in Pershing. This is just annoying. Because then what we're going to do here, Nick, is the ratio of staff to inmate population. We're going to have to use these ratios to figure out how much staff there is.
So yeah, once you find the inmates, you have to divide by 5?
You'll see, but it depends for each one, right? So we're going to do 865 minus 375 minus 125 minus 100 minus 75. Okay, so that gets us 190 inmates in Pershing. And then, okay, yeah. And then, no, you're right. They want just Pershing. And Pershing is 1 to 5. So I think you divide that by 5.
Yeah, 1
so
person
staff,
by 5.
Staff to inmate is equal to X over 190. And then...
Yo, how bad are they that they need 5 staff for 1 person? For each person? What the hell?
No. They have 5 inmates for every 1 staff. It's 190 over 5.
Oh. Dude.
Yeah. So 38 actually. Yeah. So they have 38 staff. So yeah, they actually are outnumbered. But I guess there is a prison system like keeping them in place. Okay. In 2000, the percentage of the total inmate population of Perryville's correctionally held at Grant facility was most likely. Okay. How do you think you figure out this? The percentage at Grant. So remember percentage, right? So it says percentage of the total inmate population. So you have to add this first to get total inmate population, okay? So that's 90 plus 140 plus 150 plus 200 plus 300. And then Grant facility had 150, so you do 150 divided by that. And that gets you 17%. Okay, so 17% were there. The average number of personnel at Perryville's correctional facilities in 2000 was most nearly. Average number of personnel. Do you just average these?
That's every facility.
Yeah. What's up, Mondo?
That's dope.
We're learning about prison.
We're learning about prison.
We're We're learning about how the prison industrial complex, like, you know, pays for things. 1, 2, 3, 4, 5 divided by 5. Okay, I think it's just 37. Oh, wait, that's not any of them. Oh, it's most nearly 38. Yeah. 30, 20, 25, 50, 60. Okay. Of the following, the facility which showed the greatest percentage increase in the number of inmates was... Okay, percentage increase. So, do you know how to calculate percentage increase?
Yes.
Okay.
Something minus initial
It's
divided by
final.
initial
Finest minus initial
Yeah.
divided by initial. Yeah, very good.
times 100.
Times 100. That works too. Yeah. So, here, this is going from 75 to 90, so that's 15 over 75. That's like 20%. That's not very big. 140 from 100, that's 40%. That's pretty big. Marshall went down. Pershing didn't go up by that much. Grant didn't go up much. So it's Jackson. It's Jackson.
Damn.
If for 2001 the total inmate population increased by 200 inmates, the percentage increase over the total 2000 population. Did we calculate the total 2000 population? I think we did at some point. Yeah. It was 880. So you do 200 divided by 880. And that gets 23%. Nice. Good. There we go.
Wait, can you explain that one again?
Yeah, so they said if for instance there's another table like 2000, so this is 95, this is 2000. They're like, let's say we have another table for like 2001. And they're saying that the total inmates increased by 200, okay? So that means your final minus initial is 200, right? Because that's your difference between the final and the initial. That's the increase. Then you have to calculate the initial population, the initial total inmate population in the year 2000. And we did that already. That was adding all these up. These added up to 880. So that's why you just do 200 divided by 880 and you get like, yeah, 0.22 or something. Cool?
Got it. Thank you.
Nice. You're welcome, dude. Okay, I'm starving. I want food. Mondo, are we getting on? Are we playing finals, dog? I'm a free man now. I just have to grade some final exams, so I might as well play the finals. Well, there you go. There it is. Download Blitz. Yeah. Okay. I don't see any questions yet. No more questions. And you'll be on a little bit. Yeah. Hit me up, Mondo. Hit me up. Message me when you're playing. There we go. Perfect. Yes. Let me know. We'll play. Okay. All right. That being said, yeah, let's close out the stream. Thank you everyone for coming to Office Hours, Actual Education. I had a real fun time working with you guys. Lots of great questions. Again, if you're just finding us here from like YouTube or Twitch, welcome. Please feel free to, like, subscribe. You can also join our Discord, which is like right there. That's a great way to get involved with the community and get your questions answered. But also, if you want to help out, we have a bunch of other students, especially in the next month or two when school starts, that are going to need help. And if you want to come by and answer some questions for them, you can totally do that as well. Yeah. Very welcome, Taco, as well. Our next stream is going to be tomorrow. That'll be at 5 p.m. Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Come on by, hang out, learn some stuff, get some help. Give me purpose in the afternoon. I don't know what to do with myself now that I'm not teaching. I do really need to start getting ready for Burning Man, though. Yes. Thank you, Don. Thank you for coming by, Don. You're a great guy. Yeah, make sure go follow all our other awesome math streamers. There's a list of them they also stream on Twitch and have some pretty dope streams. Okay, let's see who's on today. Who are we gonna go read? Who are we gonna read? I like Nerduino. He's a cool guy. Looks like Nerduino's chatting about space, comets, all sorts of fun stuff. Yeah, go say hi to Nerduino. He's a great guy. Love all the science and math people on Twitch. Okay. Enjoy the rest of your Tuesday. We will see you tomorrow. Peace.
We'll go supernova, right? Well, that's a different kind of event. This is sort of the slow.
Please clear
This is
the
the slow.
landing.
Raiders, welcome in. Dark aspect.